We are working on question 4 now. So for our first question, from the nameplate, calculate the output power of the motor in kilowatts. So we're given the output power not in kilowatts, but in horsepower on this. So the question is simply a matter of going 30 times 746 equals. So 30 times 746 equals, and we get 22380 watts. That is our output power, as the horsepower value is always given in the output power. We have a look at our model answers, shows horsepower times 746, so 30 times 746 equals 22.38 kilowatts. Now, so to change to kilowatts as well for this question, we move the decimal place 3 to the left, which is how we get our 22.38 kilowatts. Question B, from the nameplate, calculate the input power of the motor in kilowatts. This is as simple as going output divided by efficiency, and our efficiency is shown as our N percentage, so 93.6. We have 0.936 because we need to convert it to a decimal rather than a percentage value, equals our input. Now, our output is from there, and our 0.936 is going to stay the same. So input equals, and so we've already got our value saved on the calculator, so we just divide that by 0.936, and that will give us 23910.26 watts. When we look at the model answers, it says 2391 kilowatts. Got to move our decimal place 3 to the left, which makes it 23.91 kilowatts, ignoring the rest, which would have matched the model answers. Now, moving on to question C. So, looking at our question C, we have calculate the motor output power required to drive a full load torque of 142.63 Newton meters. Now, we have a RPM at full load given to us at the beginning, which is 1440 RPM. So that is our full load RPM torque there. And we also have our 142.63 Newton meters. As we change over to this page here, we have P external, or output power, equals 2 pi NT over 60. Now, we are interested in our external power, not our input power. So we go back to our previous question where we worked out the output power. So it's 22380 equals 2 pi. Our N is our RPM, which is 1440. And our T is our torque, times by 142.63 over 60. Now, this is what we hope it's going to be greater than. It doesn't mean it is. So we go 2 times pi times 1440 times 142.63 equals, we get 1.29 million. We divide that by 60, and we get 21,508 watts. Move it to up 3 decimal place, and it's 21.5 kilowatts. And so, as we have worked out, it is 21.5 kilowatts is required, and the motor can output 22.38 kilowatts. Yes, it may make the motor go, as per our questions on C1 and C2. Calculate the line current drawn by the motor. So For this one here, we need to get our values once again. And we're dealing with the output power. So our output power is 22.3 at kilowatts. And we need to divide that by its input, which was our 0.936, and that gives us our output our input power of 23.91 kilowatts. That's input. Now, because we have a power factor of this, and our power factor is because our power factor is 0.87, we actually have to divide this divide this input by 0.87 to get the total input power. So that gives us 23.91 divided by 0.87, 27.48 kilowatts. Now, we want the line current. Ultimately, we are working on a three-phase. I think we mentioned it somewhere. Three-phase 415 volt. So VA equals power equals whatever. We've already done the VA part. So power, which is our VA 2748 equals root 3 times V line, which is our 415, times by I line. We divide both sides by root 3 times 415, root 3 times 415. So we have our root 3 times by 415 equals two 7480 divided by close bracket square root of 3 times 415 close other bracket, and we get 38.23 amps. Okay, answer sheet, I get 38.24, subtle difference from rounding. Might redo that one later.